My name is Michael Anderson, and I'm from the MRC Cognition and Brain Sciences Unit at the University of Cambridge. And the title of my talk today is Amnesia and Healthy People by Hippocampal Inhibition, a New Forgetting Mechanism. And before I get going today, I'd just like to express my profound gratitude to EPS, Experimental Psychology Society, for awarding me the Mid-Career Award in Experimental Psychology. It's truly an honor to receive this award, and I'm quite grateful. I'm just sorry I can't be able to speak with each of you in person due to the pandemic. But it's a pleasure to be able to share with you some of the work that we've done that's relevant to this award, which I look forward to today. I'd also like to thank Pierre Gagnepan for his kindness in organizing a symposium on memory inhibition, which many of you will have attended, hopefully, this morning, as well as the speakers, Robert and Elizabeth Bjork, Maria Wimber, Roland Benoit, and Datsap Spalka. Thank you all very much for doing a fantastic job. Before I get going, I'd just like to say that the work that I'm going to present to you today was done in collaboration with Justin Hulbert, a brilliant former PhD student in my laboratory, who's now the director of the Memory Dynamics Lab at Bard College. And this was a true pleasure to do the work with Justin, who was really fun to work with, and he deserves a lion's share of the credit for a lot of this work. My talk today is about amnesia. Now, as everyone knows, amnesia refers to a severe deficit in memory arising as a result of damage to a brain structure involved in memory, for example, the hippocampus. And perhaps the most canonical case of organic amnesia is amnesic patient HM, short for Henry Molaison. And this is a picture of Henry as a young man in the 1950s. And Henry's is a sad story. As a young man, he started to develop epileptic seizures, which grew so bad over time that his parents grew desperate and enlisted the help of a neurosurgeon to help ameliorate some of his worst symptoms. And the neurosurgeon proposed an intervention in which the left and the right hippocampus of the brain would be removed to reduce the epileptic seizures. And the rationale for this was that the hippocampus was a source of electrical instability that generated a lot of his seizures, and removing it might help. Well, little did they know that in removing his hippocampi, it would render poor Henry profoundly and permanently amnesic. Henry never stored another episodic memory for the rest of his life. He was essentially a ward of the state until his mid to late 80s, when he finally passed away, and never having acquired another new fact. And in fact, he lost some of the memories that he had already stored in memory prior to the surgery as well. So he suffered a retrograde amnesia as well as an anterograde amnesia. And this is an image of a coronal slice of Henry's brain taken with MRI. And the darkened areas within the white rectangles are where Henry's hippocampi ought to be, but they're not there because they were surgically removed. And the discovery of such a profound instance of forgetting arising from such a focal form of brain damage, I think, was a watershed moment in the history of memory research. It set off a revolution that has studied the role of the hippocampus in forming long-term memories. Over the last 70 years, just a veritable mountain of research has been accumulated. And the purpose of my talk today is not to talk to you about the recent work that I've done on organic amnesia, or even about neuropsychology, but rather to talk to you about an intriguing idea that Justin Hulbert and I hit upon early in his PhD career, which is the possibility that organic amnesia may not be limited to cases in which there is structural and permanent damage to the hippocampus, but might also arise in otherwise healthy individuals from processes that suppress the functional activity in the hippocampus, that degrade hippocampal state. The proposal here is that there exist cognitive operations of the sort that we study in EPS, that have as their outcome the suppression of hippocampal activity and the disruption of its functional state that result in characteristics of amnesia that are much like those suffered by HM, but just occurring in a briefer window of time. And of course, we thought that many cognitive processes might have this effect, but the one that is near and dear to our hearts, the one that we chose to focus on, is retrieval suppression. Retrieval suppression refers to, well, in a retrieval suppression situation, you get a reminder to an experience stored in long-term memory, and the reminder is powerful one such that when you see it, it automatically and reflexively elicits a retrieval of the associated event. And the question is, to what extent can people focus their full attention on that reminder, but nevertheless willfully prevent the associated memory from entering consciousness? Can people stop the retrieval process or suppress the retrieval process? And that is the essence of retrieval suppression. It's stopping retrieval. And retrieval suppression is the kind of thing that you would do if you got a reminder to something that you'd rather not think about, an unwanted thought, an unwanted image, an unwanted memory, and you kind of went, I don't want to think about that right now, and you shut things down. Well, that shutting things down, that's retrieval suppression. And retrieval suppression is typically operationalized in the laboratory using the think, no, think task, which you've heard quite a lot about in some of the earlier presentations today. And the think, no, think task basically puts people in the situation I just described. So you present people with reminders to things that they've encoded in the laboratory. And on some trials, you ask them to retrieve the thing that goes with the reminder. And those are the think trials. And on other trials, you tell them to not think about the thing that goes with the reminder, to stop themselves from remembering or retrieving. And those are the no think trials. And the vast majority of the work that's been done with the think, no think task has concerned the mnemonic after effects of exercising retrieval suppression. So what's typically found is that if you repeatedly suppress something, that eventually it becomes harder to recall the things that you've suppressed. Your memory gets worse. And that phenomena is known as suppression-induced forgetting. And suppression-induced forgetting is actually not at all the point of what I'd like to talk to you about today, even though many of our speakers were focused on that. Rather, what we're going to be interested in here is what we're going to be exploiting here is the fact that retrieval suppression reduces hippocampal activity bilaterally so that we can ask the question of whether that creates a state that is much like organic amnesia as suffered by HM, even if it only occurs in brief windows of time. And just to show you that hippocampal activity is genuinely reduced by retrieval suppression, here is an example. And this example was produced courtesy of Datsa Upschwalke, one of our speakers today. And what Datsa has done here, she's taken probably 10 or 12 different data sets from the laboratory comprising 330 participants and painstakingly hand tracing the hippocampus on the left and the right side for each of them, and then plotting hippocampal activity in the head, body, and tail of the hippocampus, as you can see here, as a function of whether or not people actively retrieved an associated memory, depicted in green, or suppressed retrieval of the associated memory, as depicted in orange here. And you can clearly see that retrieving something upregulates hippocampal activity, but disengaging retrieval or suppressing retrieval downregulates hippocampal activity. And this is an extremely robust effect, as you can see. Essentially, suppressing retrieval makes the hippocampus go dark. And if that's really true, does that create an amnesic effect, much like that suffered by poor Henry? It's not an accident that we just happen to be asking this set of questions. The reason that we're asking it has to do with a comment made by an undergraduate student in one of my introductory psychology classes. And this was a lecture on organic amnesia. And when the student raised her hand and made the following comment, she said, "I think I once had organic amnesia." To which, of course, the class laughed, thinking she was just joking about how terrible her memory was. But the student was extremely serious. And she went on, she really felt that she had organic amnesia at one point and then recovered from it. And she went on to explain to us that she had been involved in the tragic Columbine High School shooting. And this is Columbine High School here. For those of you who don't know, this is one of the sadly frequent occurrences that happened in the United States where two psychologically disturbed adolescents got hold of some firearms and then went to high school and shot a lot of their classmates and some of their teachers as well. And this poor student had been in this event. And she explained how in the aftermath of this, after some time had gone by, her parents, their parents in general, uh, decided that it might be a good idea for the students to start attending classes at the high school again, to achieve some sense of normalcy once again. And you can kind of understand this perspective, right? But if you think about it from the student's perspective, what must that have been like? Going to the campus again and walking through the high school and seeing all the places where these incidents had taken place, I just can't imagine what it must have been like. And so the student explained that when she started to attend classes again, she developed serious memory problems, serious deficits in memory for everyday events, and that the characteristic of this forgetting really seemed to match my description of what was going on in HM and during my lecture. And this set me and Justin to wondering whether this student may have been doing something like this to herself, and somehow downregulating hippocampal activity. And to imagine why that might be true, imagine a day in the life of this poor student. So the student arrives at high school on the bus and has a lovely chat with her friends in the morning. And then the bell rings and she starts to walk up the stairs to go into the high school with her friends. And this is one of the places where a tragic incident had taken place, a shooting had taken place. And what would you do if you were this student? Well, we think that she was probably trying very hard to not think about those events so that she can maintain her composure and talk to her friends. And so she would be trying to suppress the retrieval process. And if she really is suppressing the retrieval process, and if that suppression downregulates hippocampal activity, then it's possible that the event that occurred immediately preceding that, which formed a representation in the hippocampus and was the hippocampal dependent, might then be lost as a result of that, in a form of retrograde amnesia. And after walking up the stairs, let's say she walks into a hallway where no tragic incidents had taken place, which might otherwise be encoded perfectly well, but in this case, maybe doesn't get encoded perfectly well because of the lingering after effects of hippocampal suppression, maybe creating a form of anterograde amnesia, at least partial anterograde amnesia. Then she goes to the library where another tragic incident had taken place, and she tries to suppress retrieval again and loses even the fragile memory trace that she had formed just moments before. Then she attends classes and tries to learn some things, but doesn't maybe learn them quite as well as she should because of a degraded hippocampal state. But then she walks down the hallway and sees another place where a tragic incident takes place, and she loses even that. And so one way of thinking about this is that whenever one suppresses retrieval, that retrieval suppression may come along with an amnesic shadow, which is a memory deficit for experiences occurring in the temporal surround of the incident of suppression, so beforehand and afterwards, retrograde and anterograde amnesia. And so we thought it would be very interesting to test for the existence of the amnesic shadow. And so we did this by adapting the typical think, no, think paradigm. And a simple example of which is illustrated here. Now, this is a very simple example with word pairs. Other instances of the paradigm exist using picture pairs, for example, as you heard about in earlier presentations today. If you were a participant in this experiment, you would participate in three main phases: a study phase, a think, no, think phase, and a final test phase. And in the study phase, you would get several dozen paired associates to learn, and you'd be drilled on them until you knew them fairly well. This establishes a linkage between reminders and memories, which we can then use to study retrieval suppression. In the second phase, there's the critical think, no, think phase, where people are going to exercise control over the retrieval process. And it's composed of two main trials, the no think trials and the think trials. And the no think trials, a reminder to one of the previous pairs is presented in red. And red is the signal to the participant that they should stop the retrieval process. They should focus on the reminder, but nevertheless shut down the retrieval process. Don't allow the associate to enter consciousness. Whereas on think trials, the reminder would be presented in green, and that's the participant's signal that they should go ahead and retrieve the associated memory and keep it in consciousness for the duration of the trial. And trials of these two types are done on different pairs of words. of course, and then a given item is either suppressed or it's retrieved multiple times to maximize the impact of this manipulation. And immediately afterwards, we test their memory. We either give them the same cues, like ordeal, steam, and rent, to recall the original responses, or we give them novel independent cues. So for example, insect for roach. And the vast majority of the work using the think, no, think task has focused on the behavioral outcome here as a function of whether items are no think, think, or baseline items, whether as a function of this intervening manipulation. This is not going to be the focus in the present presentation. Rather, we're going to focus on things happening in the think, no, think phase itself. And to illustrate how we adapted the think, no, think paradigm to test for the amnesic shadow, I have to introduce you to this chap. This, of course, is a peacock in a car park. You might ask, what is the peacock doing there and how did it get there? And if you did think that, you would basically be doing the same task that we asked our participants to do. We gave them a bunch of pictures like this, and we asked them to explain covertly to themselves how the centrally located object came to be in the location that it was. And then to rate how difficult it was to construct that explanation on a scale from 1 to 4. And of course, we weren't very interested in their ratings. That was just a ploy to get them to associate the centrally located object to its setting, because later on, we're going to give them the setting without the object and ask them to remember what they saw. You might think that that's not very hard. Of course, I can remember seeing a peacock in a car park, except for the fact that we gave them about 40 of these, and we tested them 45 minutes later. And most importantly of all, to make matters worse, they did this explanation task in a very challenging context. So this is a typical trial sequence of the adapted think, no, think task that we constructed for these experiments. And you can see that our poor friend, the peacock, and the explanation task is nestled or embedded in between the think and the no think trials. And the idea here is to try to mimic the experience of our poor student. So let's imagine that the student stops in the hallway where nothing tragic had happened, is having a nice, lovely conversation with her friends, and is laying down an incidental memory for that conversation with her friends. And so you might ask, how well is that experience going to be remembered as a function of whether or not the student had just, a few moments earlier had suppressed retrieval to not think about an unpleasant memory, or maybe afterwards had done that. And so that's the situation we're trying to mimic here. Now, you might be wondering what these numbers are all about. That's another task that we gave to our participants. It's an odd-even judgment task. So they just judged whether numbers are odd or even as quickly as possible. And they did that for about 5 to 10 seconds before the peacock, as well as 5 to 10 seconds after the peacock. Now, the purpose of this odd-even judgment task was, in the first instance, is to control for task set switching effects. We didn't want to put the think, no, think task immediately before the peacock, because there might be a task set switching effect from that task into the peacock, which might cause distraction in the encoding of the peacock. And more to the point, there might have been differential distraction in switching out of the no think condition compared to the think condition. And we didn't know, we wanted to eliminate that possibility. So we inserted this buffer task to match the task set switching costs across the two conditions. So they were held constant entering the peacock trial. The numbers afterwards served a different purpose. And here we were concerned about lingering thoughts about the peacock. I mean, who wouldn't want to continue thinking about the peacock, right? We wanted to kind of clear the mental palette, shall we say, by inserting 5 to 10 seconds of a demanding, distracting task, so that they eventually would stop thinking about it prior to the next think or no think trial. So you can conceptualize this manipulation as allowing for a dose response manipulation of the number of epochs of suppression surrounding the peacock. This peacock could either be surrounded by 0 epochs of suppression, in which case the surrounding trials would be think trials, 1 epoch of suppression, as in this case, or the suppression could occur afterwards as well, or the 2 epoch condition, in which our poor friend the peacock is surrounded on both sides by retrieval suppression. And we refer to the episodic memory that's formed by processing the peacock as a bystander memory. It's a bystander memory because it's an innocent bystander memory. We're not trying to forget that, right? The participants are manipulating these things in the periphery. So to the extent that it suffers as a result of what's going on in the temporal surround, it's an innocent bystander effect, if you will. So the main question then is, does the amnesic shadow exist? Does it occur? Is there a recall deficit for the peacock and other objects as a function of the number of epochs of suppression that surround the peacock? And the results of our first experiment are here. Just to show you, this is the percentage of items correctly recalled on the final test. This is bystander recall of these objects now, not TNT recall. Plotted as a function of whether the peacock was surrounded by 0 epochs of suppression, 1 epoch of suppression, or 2. And what you can see is that when the peacock is surrounded by no suppression, that they recall the peacock reasonably well. It's around 52% of the time they can recall these objects. But if you surround this scene by 2 epochs of suppression before and afterwards, performance drops nearly in half. So virtually, they drop down to about 28% recall. This is a pretty massive drop-off in performance simply by surrounding the thing by suppression. The 1 epoch of suppression condition is somewhere in between those two. So we have this kind of dose-response function. Now, it's important to emphasize that all manner of factors that could potentially cause forgetting have been held constant across these conditions. So, for example, the retention interval in between the encoding of the peacock and the final test is constant across these 3 conditions. The amount of time that they spent processing the peacock and the judgment reaction time, for example, is identical across these 3 conditions. We checked. The potential for proactive or retroactive interference is constant across these 3 conditions. So the only thing that's really different is what's happening in this peripheral modulation of hippocampal activity, either beforehand or afterwards. And so we really seem to have evidence that suppression causes an amnesic shadow, consistent with the possibility that the student may have been causing her own memory deficit. Now, if this is what's really going on, then retrieval suppression is disrupting the functional integrity of the hippocampus. It's disrupting the ability of the hippocampus to encode, and also the ability of the hippocampus to stabilize or consolidate memories, both of which suggest that this really ought to be an enduring effect. And if that's true, then we should be able to see this effect after a 24-hour retention interval. And we tested that in a second experiment. And sure enough, we basically found the same thing, even after 24 hours. Now, of course, overall performance was much lower after 24 hours, unsurprisingly, but you can, again, see that this dose-response function is true here as well. So the effect does persist after 24 hours, consistent with the predicted enduring effect. Now, up till this point, I've been arguing that this amnesic shadow effect is produced by retrieval suppression. It's caused by retrieval suppression. But do we know that this effect is really selective to suppressing the retrieval process? There are other ways that you can try to control the influence of unwanted memories. For example, Zara Bergstrom and Roland Benoit have both studied the distinction between direct suppression on the one hand and thought substitution on the other hand. And we decided to see whether or not the amnesic shadow always occurred regardless of the type of forgetting method, or only occurred when you tried to shut off the retrieval process. So in this experiment, we replicated the prior work, and the participants could be assigned to either directly solve the no-think task with direct suppression or with thought substitution. And if you were in this experiment doing direct suppression, you would be given instructions pretty much identical to what I've told you about up until this point. So people had to focus on the reminder and try to prevent themselves from retrieving the associated memory, and to do so by not thinking of distracting thoughts. We told them, don't think of distracting thoughts, just focus on the reminder and prevent the associate from coming to mind. And if it does come to mind, then push it out to disengage the retrieval process. Whereas in the thought substitution condition, participants were instead told to try to prevent themselves from thinking about the unwanted memory by retrieving an alternate thought or a thought substitute, one that we told them to retrieve earlier, stomach for diet, for example, and to occupy their awareness with that distracting substitute thought, which is very successful, by the way. People can do this. And both of these methods produce forgetting on the later memory test. But what's interesting is that Roland Benoit demonstrated back in 2012 that whereas direct suppression downregulate, this is hippocampal activity that we've plotted here, whereas direct suppression downregulates hippocampal activity, thought substitution doesn't downregulate hippocampal activity. And this makes a good deal of sense because thought substitution requires retrieval. Retrieval requires the hippocampus, so you can't downregulate hippocampal activity during thought substitution. And this provides a very elegant manipulation that then is matched with respect to the participant's goal. In both cases, they're trying to not think about the unwanted memory. But in one case, they're achieving that by suppressing or shutting off the retrieval process. And in the other case, they're achieving it by engaging the retrieval process to think of the thought substitute. So would thought substitution generate an amnesic shadow as well? And the answer is no. So the recall of the peacock did not vary as a function of whether or not it was surrounded by 0, 1, or 2 epochs of thought substitution. But it did vary as a function of whether or not it was surrounded by the corresponding number of direct suppression attempts, beautifully mirroring the pattern of data, of brain imaging data in the hippocampus. So this really suggests that the amnesic shadow is selective to retrieval suppression, and it's not just about forgetting something, it's about forgetting it by shutting off the retrieval process. Now, an alternative possibility that's worth considering is that it's not retrieval suppression per se that causes the amnesic shadow, but rather some other attribute of retrieval suppression that goes along with it. For example, maybe retrieval suppression is just particularly difficult. So maybe trying to exclude an associate from awareness when confronted with a reminder to that associate is just particularly difficult, maybe more difficult than thought substitution. And so by this logic, then, it's not that there's something special about retrieval suppression. It's just that difficult things are distracting, and distracting things disrupt hippocampal function. And that if that's really true, then we should be able to construct an extremely difficult task that doesn't involve retrieval suppression that produces this amnesic shadow effect as well. And thus was born the think harder task. In this task, the think component of this task is identical to the think component in all the preceding experiments. What's new here is that we've eliminated the no think condition and we've replaced it with the think harder condition. So what is this think harder task? Well, if you were doing this think harder task, you would get one of the reminders in red, as in this example. And now, instead of trying to suppress retrieval, we would actually ask you to retrieve the associate. So retrieve cream with diet. But in addition, you would also have to retrieve an alternate. In this case, we told them to retrieve scone. So they retrieve cream and scone. And then they would have to compare the strength of the association between the target and the alternate, cream and scone, relative to the association between cream and a brand new item that we're presenting to them on the screen, milk. So you have to judge, is cream scone more related or cream milk? You probably would decide cream milk is more related. And if that's true, then you'd have to replace scone with milk. And thereafter, milk would be the alternate that you would compare things against. So this is a very complicated task, and the subjects particularly, they just basically hated us for this because it was so hard. But would this very difficult task that didn't involve retrieval suppression cause an amnesic shadow effect? And the answer is absolutely not. So the recall of the peacock did not vary as a function of whether or not it was surrounded by 0, 1, or 2 of these preposterously difficult trials. And in case you're wondering whether or not participants really thought it was difficult, here are their ratings of difficulty. And clearly, the think and this think harder task differed robustly in terms of the perceived difficulty that participants experienced. So this really suggests that difficulty or distraction just isn't sufficient to explain the amnesic shadow, and that it's something specific about the desire to disengage the retrieval process, the process of disengaging the retrieval process that produces the amnesic shadow. Well, so I think I've argued that retrieval suppression causes an amnesic shadow because well, I think the data up until this point really convincingly show that retrieval suppression, there's something special about it that causes the amnesic shadow. And we've attributed that to the downregulation of hippocampal activity, but we haven't actually shown that, right? To show that, we actually would have to link the amnesic shadow to hippocampal activity. And if we're going to make this argument that it's mimicking organic amnesia, we'd better well make that link. And so we ran a functional magnetic resonance imaging study using this amnesic shadow paradigm. And the goal of this procedure, the goal of this experiment was to quantify activity in the hippocampus bilaterally, and then to quantify the extent to which hippocampus was downregulated for each of our participants, and to ask whether or not that was related to the size of the amnesic shadow that they exhibited on the later memory test. So the prediction being that the hippocampus would, when the hippocampus was more deeply downregulated, a greater amnesic shadow would materialize. And that prediction was very, very strongly confirmed. Hippocampal downregulation does indeed predict the amnesic shadow. And you can see that over here. On the x-axis, we have hippocampal modulation, so with scores to the right indicating deeper downregulation of the hippocampus. And on the y-axis, we have the amnesic shadow effect, so with higher scores indicating a larger amnesic shadow. And you can see that there is a strong positive correlation between these two, a correlation of 0.55. So the deeper the downregulation of hippocampal activity, the larger the amnesic shadow effect was. And this part on the right simply shows that the engagement of the prefrontal cortex predicts downregulation of the hippocampus. So the more engaged the right prefrontal cortex was, the greater the downregulation effect was in the hippocampus. And so here we have the full picture. So we have the active downregulation of hippocampal activity and the linkage of that downregulated activity to the amnesic shadow effect. So taken together then, these findings really suggest that we have evidence that retrieval suppression not only downregulates hippocampal activity, but induces a degraded functional state in the hippocampus that creates windows of amnesia with many of the hallmarks that were present in organic amnesic patient HM. And this is accomplished by retrieval suppression. Now, the striking feature of these results, and if you think about what people are suppressing here, what are they suppressing? They're suppressing these arbitrary neutral word pairs, and they're that are totally unrelated to these other things that they're forgetting. You're forgetting the fact that you saw a peacock in a car park because you suppressed ordeal roach. Who in the world would ever think that? You know, how could that possibly happen? And we certainly would not have thought that that would happen had we not had this theoretical analysis that basically that suppressing retrieval degraded hippocampal function globally and should disrupt any memory that was hippocampally dependent as a result. And so that predicts this bizarre effect where something totally unrelated can be seriously disrupted by suppressing a random word pair. So this really suggests that the student's experience of severe memory deficits when she started attending her high school again might have had their origins in this kind of dynamic. I mean, we can't say for sure, of course, and there may be other factors involved, but based on these studies, we are convinced that this is at least a contributing factor of amnesic deficits in general after trauma. By the way, when I say that inhibition is mimicking amnesia here, I really mean inhibition. In a recent study by Taylor Schmitz in 2017, we quantify, using magnetic resonance spectroscopy, we quantified individual variations in the concentration of GABA in the hippocampus. GABA is the chief inhibitory neurotransmitter in the hippocampus. And what we found is that the more GABA that you had in your hippocampus, as measured by spectroscopy, the more effectively you were able to downregulate hippocampal activity, and the more effectively you were able to forget the memories that you were trying to suppress, and the more effectively the prefrontal cortex could modulate hippocampal activity. So there really seems to be something pivotal about GABAergic inhibition in the hippocampus that's inducing this dysfunctional state. So inhibition of hippocampal activity is mimicking organic amnesia. Now, you may at this stage believe that we have made a persuasive case that retrieval suppression induces this reversible form of organic amnesia, and that it may well be behind these kinds of trauma-induced forms of memory deficits. But I think you might also be reasonable in taking a skeptical stance about how general this effect really is. I mean, I made the argument at the beginning of the talk, you may recall, that we may have on our hands here a general forgetting mechanism that has not previously been identified. But is that really true? I mean, all we're showing really is that in the 5 to 10 seconds before a period of suppression, you forget newly encoded material. And maybe to the extent that suppression only happens when you're really traumatized by something, this doesn't exert such a big effect on retention and long-term memory. So what about the whole rest of memory, things that are already successfully encoded, for example? Those, would they have already escaped the amnesic shadow? So presumably they would be invulnerable to this. But I'd like to argue, based on a number of considerations, that this more narrow construal of this effect is incorrect. So, for example, take this recent work that I've done with Zhu, Anderson, and Wang, which has recently been submitted, in which we ask the question of whether the amnesic shadow can disrupt existing memories. So not just recent things that you've encountered, but things that you've already stored in long-term memory might be vulnerable to the amnesic shadow. Well, how could that be? We thought, or the main idea is that maybe if you simply remind people of a previously stored memory just before they do retrieval suppression, it would render the memory vulnerable to the amnesic shadow. So maybe it would reactivate a trace or activate a trace in the hippocampus that would make this already formed memory also vulnerable to disruption. And let me show you how we went about testing that. So let's focus on the bottom here. So we adapted the typical think, no, think task to test this question. And of course, as in the many preceding TNT tasks that I presented to you, the main TNT materials were simple pairs of words like bride, train, soldier, and cream, and so forth. So those would be the things that people are doing the no-think trials on and the think trials on. So what's new here is that we've also asked people to commit to memory for some additional pairs involving scenes. So either having them encode the scene in relation to an object cue, as in this first phase, or those same scenes would be re-encoded again in the second phase, now with new cues, verbal cues. So each scene is associated to 2 different cues. Now, these materials, these additional materials, are the things that are successfully encoded into long-term memory, and we're going to see whether or not reminding people of those memories during the think, no, think task makes them vulnerable to disruption. And just to illustrate how this happens, here is a typical trial sequence in the think, no, think task. And so here we have a no-think trial followed by the odd even judgment task. And now, instead of encoding something new at this phase, we present people with a reminder to something that they've already encoded. So this doll is a reminder to this unpleasant scene that they have it paired with. Would simply incidentally reminding people of those scenes render this thing less accessible? And of course, we inserted these reminders between think trials as well. But one interesting additional manipulation that we did in this experiment, which is really fascinating, is that we manipulated whether or not these objects were consciously perceivable. So here is an example of a consciously visible cue, but down here, I've illustrated that for some trials, we've also presented the cues in masked fashion. In fact, we presented the cues repeatedly and masked them. And we verified that participants simply could not identify what these things were on a trial-by-trial basis in one of the experiments. So we successfully prevented awareness of the object. But the question is, would that reactivate the memory nonetheless and render the memory vulnerable to disruption as well? And here's what we found in this experiment. So on the y-axis, we have the percentage of these bystander scenes that were correctly recalled. And we have this for the trained cue condition, which is this first bunch here. We call it the trained cue because it was presented overtly in between these trials. And the independent cue condition is when we tested the same scenes with a secondary cue that we encoded in the second phase. And none of those cues were at all presented in this phase at all. And looking first at the trained cue, you can see that relative to performance on baseline items, the cues that were surrounded by think trials were not affected at all. It didn't matter whether this thing was surrounded by 2 think trials, it wasn't disrupted. But if it was surrounded by 2 no-think trials, performance was significantly worse. And fascinatingly, it was significantly worse regardless of whether or not they consciously saw the cue or they didn't. So reactivating an existing memory within the amnesic shadow window renders that memory disruptible, vulnerable to disruption. And you can see that effect wasn't limited to this particular cue. If you tested instead on the final test with this verbal cue, which was never seen in that phase, you essentially got the same pattern of results. So items surrounded by no-think trials were recalled significantly more poorly than baseline items. We replicated this pattern of results in a second experiment. And in this experiment, we only used non-consciously presented items. And you can see that the items surrounded by no-think trials were recalled more poorly on final test compared to either baseline or think items, regardless of whether you tested with an independent cue or the originally trained cue. So what's significant about this is that it significantly broadens the scope of the impact of retrieval suppression. It's not limited to disrupting the encoding or consolidation of recently acquired memories. It basically says anything that you've already stored that you just happen to think about, either intentionally or incidentally, that was cued, has the potential to be disrupted by a period of retrieval suppression. Now, I think that set of results shows that the impact of retrieval suppression on the amnesic shadow is broader than we had initially thought. But what about the process itself? How general is the process? In other words, more specifically, do you have to be engaged in intentional retrieval suppression of an unwanted memory to get the amnesic shadow effect? Or might there be other functional contexts that also require the disengagement, a disengagement from memory that might induce a similar amnesic shadow effect, even if it's not an intentional attempt to control an unwanted memory? An interesting fact is that working memory updating tasks like the NBAC task have this as a functional component. The NBAC task is thought of as of course, as a working memory task, but one of its features is that you have to constantly get rid of something that has become irrelevant. You have to suppress the most recently outdated items so that you can remember the newly acquired items. And another interesting fact about the NBAC task is that in addition to engaging cognitive control regions in the prefrontal cortex and parietal cortex, it also downregulates hippocampal activity robustly. And this may be linked to the fact that you have to discard certain things from memory that you no longer need. And building on that logic, Mullally and Amara in 2013 tested to see whether doing an NBAC task actually induced anterograde amnesia on the basis of reducing hippocampal activity. And so this is a depiction of of their procedure. So they asked participants to do the NBAC task repeatedly. So there were cycles here, NBAC task, NBAC task, NBAC task. And after doing the NBAC task for about a minute, they asked them to do face, name, and coding. So they asked them to memorize the associations between 10 face name pairs. And then they had a distractor task, a divided attention task. And following this, they tested people's memory for these face name associations. And then they proceeded to the second cycle where they did the NBAC task again. And then they did the face name and coding task again on the same pairs each time. And they cycled this way 4 times. And so critically, they manipulated whether participants performed a 0-back task, which was basically a perceptual task, or a 2-back task, which required working memory updating and the expulsion of irrelevant items. And this is what they found. NBAC induced process inhibition is what I would call it. So the percentage of items of faces or of names correctly recalled is plotted on the y-axis here. And these are the 4 blocks that I depicted here, block 1, 2, 3, 4. And of course, performance gets better over the 4 blocks because they're memorizing the same face name pairs each time. But the interesting bit is that relative to the 0-back condition, which doesn't require updating, the 2-back condition produces a pronounced deficit in the ability to recall these face name pairs. I think 20 or 30%, I guess more than 20% on average, which was consistent with Mullally and Amara's hypothesis that that they would observe an anterograde amnesia effect due to the NBAC task. So Mullally and Amara's finding, I think, very clearly indicates that, well, to the extent that these are the same phenomena, I think that needs to be carefully evaluated. But at first blush, it would seem to clearly indicate that one does not need to engage in intentional suppression of an unwanted memory to get the amnesic shadow, that other functional contexts that require the disengagement of memory might also produce it. And then the question becomes, how often does that happen? How often do we need to disengage from memory? And I would like to offer a hypothesis for the future that needs to be evaluated, that a broad distinction that may predict when memory needs to be disengaged or not may be the distinction between external versus internal attention. Now, clearly, external attention refers to attention to perception, to attention to vision, to attention to audition or somatosensation. Internal attention refers to attention to memory, attention to ideas, attention to feelings, for example. And it's an interesting possibility that when one's attention is focused externally, particularly when the demands of an external attention or perceptual motor task are very high, it may be maladaptive to dwell too much on one's internal thoughts. It may be distracting and undercut performance. And so as a whole, it may be useful to disengage from meditation and from memory while doing a difficult and distracting task. Now, what retrieval suppression might be a special case where the participant voluntarily, intentionally tried to disengage from memory because they just didn't want to remember, like, I don't want to, they intentionally engage that process. But maybe there are other processes that entail that as a functional implication, even if people don't consciously do it. And there's some very intriguing support for this possibility. For example, we've known for about 2 decades about the existence of default network suppression. And for those of you who don't know, the default mode network is a collection of regions that are often activated when people are basically mind wandering or left to their own devices. These set of regions are strongly functionally connected to one another, generally during a resting state scan, for example, that involve the hippocampus, posterior cingulate precuneus, for example, and medial prefrontal cortex. And when one is engaged in a difficult perceptual task or a perceptual motor task, this collection of regions is generally suppressed. They're reduced in their activity. And a very interesting fact is that if you look at the brain regions that are involved, that are engaged during episodic memory in green, you'll see down here, or autobiographical memory or theory of mind, those are basically the same regions as the default mode network. So essentially, when you're engaged in difficult perceptual tasks, you're disengaging from internally focused tasks like memory and like thoughts about mental functions, for example. And so if we don't know that the tasks that produce default network suppression produce the amnesic shadow, but it's an intriguing possibility. It could be that retrieval suppression is special, the intention to shut down memory is special, but it also could be that in cases like this where it's just functional to disengage from memory and engage in something else, that you get similar pattern. And if that's true, well, we do that kind of thing all the time. We engage in interactions with our perceptual world as a preponderance of our time in the day. And that, to the extent that that has knock-on effects on how well the hippocampus functions, it could be that this kind of active inhibition of hippocampal activity contributes broadly to the forgetting process. And so, based on these considerations, Justin Hulbert and I, this last year, published an annual review of psychology article in which we argued for the existence of mnemonic process inhibition as a core component of active forgetting. And so by this idea that you can inhibit an unwanted memory, you can try to suppress an unwanted memory actively, and that's one way of accomplishing memory control and active forgetting. But we were arguing that that's not the only way, and that in fact, that suppression of hippocampal activity in general, this box represents the processes of the hippocampus. If you accomplish retrieval suppression by downregulating the hippocampus as a whole, you're not just inhibiting that memory, you're also degrading the encoding process, you're degrading the stabilization process, you're degrading the retrieval process, you're degrading other memories that were recently activated in the hippocampus and the engagement of those processes on those other memories. So I think this is properly viewed as mnemonic process inhibition and not item-specific inhibition. And then it's a qualitatively different thing that we need to be considering in our theories of forgetting. So there's a previously unidentified mechanism of forgetting. So in my presentation today, I have talked about an awful lot, and it's possible that you'll forget much of this at some point. But if you remember nothing else from this talk, the following take-home point is something you should remember, that people can forget life experiences when the machinery of memory is globally suppressed, that it's possible to induce reversible forms of organic amnesia, even in healthy individuals, just by controlling whether or not we want to engage with memory or not. And that this is a previously unaccounted for factor contributing to our experiences of forgetting in daily life. I'd just like to thank the members of my laboratory for the wonderful work that they do, and all of the work that I do is really a reflection of their collective brilliance, and I'd like to involve them as well in this award. Thank you, thanks to them, and thank you very much.